Hello and welcome to lesson 6-2. Today we're going to look at what we call proportions. Ultimately, we're going to look at solving proportions and how to use them to help us solve problems. So to look at what a proportion actually is, it's really the equality of two ratios. So what we mean by that is I could have something like 6/9 equals 8/12. In both of these proportions, if I reduce these down, I'm going to end up with 2/3. So these are equal proportions or equal fractions, okay? And if we have one of these values that is unknown, we can use what we call the cross product. So what the cross product says is if A over B equals C over D, then the cross products are going to be, we can take A and multiply it by D, and then we can set that equal to B times C. Okay, and then this will help us solve for the unknown variable, and we'll look at a few examples of this here in a minute. So to solve a proportion that contains a variable, we have to find the value of the cross product that makes that equation true. So let's go ahead and take a quick look at an example. Example 1 tells us to solve x divided by 9 equals 4 divided by 6. And we are going to use cross products. So what I'm going to do is I'm going to start out and I'm going to say x times 6. So this will give me 6x equals, then I'm going to take the product of the other side of that cross, or 9 times 4, which is 36. So now I have 6x equals 36, and I can go ahead and solve for x. So I'll divide both sides by 6, and I'm left with x equals 6. So ultimately what that means is if I were to rewrite this proportion here, I could say that 6/9 is equal to 4/6. And if I reduce both of those down, that is correct. For example 2, we have 4/5 equals t over 55. So again, we're going to use that cross product and multiply 4 times 55, which is 220. And then I'm going to set that equal to the other product of the diagonal, which is going to be 5t. I want to get t by itself, so I will divide both sides by by 5, and t then is going to equal 44. And you can always double check your work by plugging it back in for the variable and make sure that that works. For example 3, it says, do the ratios 4/6 and 10/14 form a proportion? And we have to explain why. So ultimately, we are looking to see, is 4/6 equal to 10/14? So we can prove this by doing a cross product. So I end up with 4 times 14. So I end up with 56 is equal to, if I do the product of the other diagonal, I have 6 times 10, which is 60. Well, 56 is not equal to 60. Therefore, these are not a proportion. So we'll say, no, the cross product are not equal. So now for example 4, it says photocopies at the copy shop are 18, you get 18 copies for $1.08. At that rate, we want to know how much our 40 copies going to cost. So the first thing we want to do is we want to set these up as a ratio. And it doesn't matter how you set it up. Okay, so I'm going to take, I have a complete set of data right here. So I have 18 copies. And for those 18 copies, it's going to cost me $1.08. Okay, so I could have put the $1.08 on top and the 18 copies in the bottom. So the first one does not matter, but the second one has to follow suit. In other words, you have to have the same units on the top as you do on the bottom. So because I have copies on the top in this first proportion, I have to have copies on the top over here. So my next set of data set wants to know how much will 40 copies cost me. So if I put my 40 copies on the top over here, I don't know how much my cost is going to be. So I'm going to replace that with an x, and then I'm going to go ahead and solve for x. So if I use my cross product, I have 18 times x, or 18x, equals $1.08 times 40, and $1.08 times 40 is going to give me $43.20. So if I divide both sides now by 18 to get that x by itself, I'm left with x equals $2.40. So if you're going to run 40 copies, it's going to cost you $2.40. For example 5, it says 3 tea bags are needed to make a gallon. Okay, so that tells me that I have 3 tea bags. I'm just going to write 3T is going to produce 1 gallon of tea. How many tea bags are needed to make 4 gallons? So how many tea bags? I don't know how many tea bags we need, but we need to make 4 gallons. So 4 gallons is going to go on the bottom. And again, I'm going to use my cross product. So I have 3 times 4 is going to give me 12. And then I have 1 gallon times x, so that's just x. So here, x tells me that I'm going to need 12 tea bags. Now the reason that ratios and proportions work so well is because there's a relationship. So in a proportional relationship, there's a constant that you can multiply the first quantity by, and it will get you to that second quantity. Okay, so we use an equation that we call the direct variation equation, which is y equals kx, and the k value is the constant unit rate. Okay, so this is the relationship between the x and the y. So the constant rate can be found by using k equals y over x. Now, I don't memorize this formula here. I only memorize this formula here. And if I want to get that k value, all I have to say to myself is, how do I get k by itself? Oh, I've got to divide both sides by x. Notice my x's cancel, and I'm left with k equals y divided by x. So I can find this equation if I know what this equation is. For example 6, we have to look at the data in the table and decide if it forms a proportional relationship. So when I'm not given anything specific and I have to determine if it's proportional or not, I like to just write down y equals kx. And if these are proportional here in this table, then all of them are going to have the same k value. So again, remember that k is equal to, I have to divide both sides by x. So k is really equal to y divided by x. So in my table, I have an x term and I have a y term. And if I divide those and all of them are the same, then that tells me that they are proportional. So let's go ahead and look at the first set of data right here. So I'm going to call this K1 for the first set, and I end up with my y value, which is 5, divided by 12.5, or my x. If you plug that in on your calculator, you do end up with 0.4. Then I'm going to do the same thing with the second set of data. So this will be K2, and here I have 4 divided by 10, which is also 0.4. And then for my third set of data right here, I'm going to call this K3. I have 2 divided by 5, which is also 0.4. So because all 3 of these k values are the same, then we're going to say yes, it's proportional. Okay, and if I wanted to, I could write an equation and say that y equals, this 0.4 is my k value, so it becomes 0.4 times x. And this is the relationship. Now the nice thing is when you have 2 proportional quantities and we graph them on a coordinate plane, then the points are going to appear in a line that passes through the origin. Okay, so if you look right here, like this would have been a data point possibly off from a table. This was another one. This is another data point. And if you plot all those data points out, you can see that they lay in a straight line that goes through my origin right here. For example 7, it says your distance from lightning varies directly. So when I see the term varies directly, I immediately think of that equation, y equals kx. Now because I'm dealing with a story problem, I'm going to try to plug in variables that make more sense. So I'm told that distance varies directly, so instead of y, I'm going to say d varies directly. K is that constant of proportionality, so that will always stay the same. That's always a k. So I'm told that distance varies directly with time. So I'm going to plug in a t for x. That way, as you'll see here in a minute, it's easier to know where you plug in your variable if you use variables that make sense. So as I keep reading, lightning varies directly with the time it takes you to hear thunder. If you hear thunder 10 seconds, okay, so what I'm going to do is I'm going to plug in a 10 for my time, because 10 seconds is a time. After you see lightning, it says you are about 2 miles, which is my distance, from lightning. Now we need to write an equation for the relationship between distance and time. So now what I have is I really have 2 equals 10 times k, and I need to get k by itself. So I divide both sides by 10, and I get k is really equal to 2/10, which is 1/5. So now that I've solved for k, the only thing I have to do now is I have to plug that in here. Okay, or rather this one. So I have distance is equal to, we just solved k to be 1/5 times my time, and this is my final step. Now our final example for today says your percent grade varies directly. So here's varies directly. I'm thinking y equals kx. Okay, and because I am talking about grades, I'm going to say my grade varies directly, so kx, with the number of correct answers. So I'm just going to use C for correct. Okay, then it proceeds to tell me you got an 80 when you had 20 correct. So your grade of 80 equals k times your score, or the correct answers, which were 20. So part A says to write an equation for the relationship, okay, which is kind of what we started doing here. So I'm going to solve for k, and I'm going to do that by dividing both sides by 20. So now I have k is equal to 80 divided by 20, which is 4. So when I go and I rewrite my equation, I really have that my grade equals 4 times the number that we get correct. So this right here is all for part A. And then for part B, it says, what would your percent grade be with 24 correct answers? So this really is my C value, so I'm going to try to find my grade when I get 24 correct. So I'll plug 24 in for C, and 4 times 24 is going to be a 96. So my grade will be a 96 if I get 24 correct. Please let me know if you have any questions. Otherwise, have a great day, and I'll see you in class.